Hello everybody. My name's Simon Hill and I'm a data science manager here at ShopDirect. I'm really excited to be here tonight to talk to you about a piece of work that we've been recently working on. It's an agile development of a machine learning value optimizer, and it's based around the idea of trying to better predict when the customer is leaving us, the prediction of customer churn, and then designing strategies and treatments to help bring them back to the shop. Before I get onto that though, I'd just like to start with a few facts about ShopDirect itself. So for those of you who don't know, ShopDirect is the second largest pure play online retailer in the UK behind Amazon. We trade with our customers across 4 different brand fascias: Littlewoods, Very, our luxury fashion brand Very Exclusive, and our Irish subsidiary Littlewoods Ireland. We offer our customers a wide variety of different products, from own and national brand fashion and footwear, through to homewares and big brand electricals, and support such world-renowned brands as Apple, Nike, Samsung and Ted Baker. As a group, we have sales of approximately 1.9 million a year and have around 4 million active customers on our customer database. In recent years, ShopDirect has adopted the principle of mobile first, and this is because 68% of our sales are now transacted through mobile devices. Our customers are clearly telling us this is where they want to be, so it's something that we need to listen to very carefully. So before I get into some of the modelling work we've been doing, I just wanted to give you a background and the context as to the project itself. ShopDirect, over the last 18 months, we've been building new ways of understanding customer churn. Traditionally, we used a simple view of when a customer had actually last placed an order with us, and then sent out a series of direct mail and email communications offering an increasing level of discount. This is something that had been very successful for a number of years, but recently had started to decline in performance, and as such it created the opportunity for us to do something more sophisticated, something that takes into account individual customer behaviour to better identify when a customer is leaving us, and then deploying appropriate strategies to bring them back. To do this, we've built a series of models and classifiers, which have then been pulled together to create a rule set to allow us to better understand this problem. We've been running this process now for 12 months, but essentially it boils down to two core concepts: the identification of customer churn, and then the development and application of treatments to help deal with that. On the identification side, we have 3 key models. The first and most important of which is our incremental ordering score. And this is a model that predicts which of our customers is most likely to come back and shop with us due to us contacting them. The second model we then apply is a simple view of a customer's ordering and browsing patterns. By understanding how a customer interacts with our shop, we can start to identify when they're displaying abnormal behaviour, and again use this information to help us identify what we want to do to bring them back. The third and final model is our headroom model, which is an understanding of whether or not a customer is likely to spend into their available credit they have with ShopDirect. These 3 models are then combined with our simple view of when a customer last ordered, in order to determine whether or not we want to contact a customer and send them a discount to bring them back. It all pivots around the incremental ordering score. If we believe a customer is very likely to come back because we contact them, chances are we'll send them a communication. On the other end of the spectrum, if somebody's very unlikely to come back, we're going to need to apply additional pieces of information to determine that we actually want to contact them. And chances are when we do, we will send them a smaller voucher to bring them back in that space. Once we've identified that we want to bring customers back, we then move on to the treatment side. This is achieved through the use of a simple recency frequency value segmentation. We have 60 sub-segments, all of which we have detailed information as to the likely take-up rates of different discount offers that we have available to us. At the moment, we are operating a portfolio of 5 different offers, ranging from simple small-scale percentage discounts right through to larger pounds off vouchers, such as our biggest offer at the moment is a £50 discount voucher off a minimum order of £100. For each of the sub-segments, we understand how the customers will interact with these vouchers, and as such can start to understand which vouchers are actually profitable for each individual segment. With that information, we can then start to build specific journeys, selecting only those offers we think will generate us a profitable return. These offers are stacked, starting with the lowest value offer and moving upwards, working on the assumption that if a customer is sent a low value offer and rejects it, they will then need a bigger offer to actually stimulate them to come back in the future. This program has been running very successfully for us now for around 12 months, starting from a test on 20% of our customer base and rapidly being fully rolled out. With that in mind, this has then created us an opportunity for further improvements to our models, again based around the core concepts of identification and treatment. In the identification space, we've looked at building new models to better understand customers' ordering patterns using survival analysis, and have also started to flex some of our cutoffs on our incremental ordering score. However, it's on the treatment side where we've actually spent much of the time, and it's this area that I want to spend the rest of this talk running through in a little more detail. And simply, our desired state in this space is to build a machine learning-led solution for offer optimization, which assigns an offer to a customer based on their individual customer characteristics and the overall business aims and objectives. In terms of the delivery, this has been achieved through Agile methodology, specifically the concepts of iterative and time-boxed development and the minimum viable product. This kind of project is potentially months worth of work, but one of the key goals for us was to spin up something as quickly as possible that we could start to use to test and learn and generate information that would help us further refine this. In terms of our tool set, we've largely been using the SaaS stack to help us achieve this, specifically Enterprise Miner. This is very well integrated into ShopDirect's existing architecture and makes rapid deployment and rapid iteration very achievable for us. So before I get into the detail of exactly what it is we've done, I just wanted to define the two concepts that we're using here. Specifically, what we're defining as machine learning and optimization in this space. For machine learning, we are defining this as the ability to act and iteratively learn and make adjustments without any explicit programming. To take a simple example, let's consider a system which is being built over a 4-month period. In our first month, we have relatively little data, and we take this information and run it through a series of transforms and models to generate some output. Due to the relative lack of information, we have a relatively poor predictive accuracy against an independent sample. However, over time, we're adding additional data, still running it through the same models and transforms to generate our output. Over time, our predictive accuracy improves, partly due to the increased amount of data we're running through, and also due to the feedback loop element that we're adding into this process, taking into account the results from our initial data and our initial contact. The benefit for the business is quite clear for us. This is a process that essentially becomes repeatable and reliable, and in the case of the system we have built, something that requires relatively little human intervention to keep running. The second concept we're looking to cover is around optimization, which is simply the most effective use of a situation or resource. In this case, I'd like to run through a very simple example using 3 of our target Miss Ferry customers. In our initial scenario, we have the information as to the performance of 3 different discount vouchers for each of our 3 customers. And our aim here is to simply maximize the profitability of this system. In this case, we'll send the first customer offer B, the second customer offer C, and the third customer offer A. This will generate us £42 worth of value at a cost of 21. However, it's not quite always as simple as trying to maximize value given no constraints. So let's say we actually have a marketing budget constraint. In order to generate our value, we can only spend £15. As such, this scenario that we've started with is too expensive. Whilst it's maximised the profitability of the various different discount offers, it's cost us too much to get it. As such, we're applying the budgetary constraint, and in this case, we'll send the smallest value offer to all 3 of our customers. For the first 2 customers, that's offer A, and the third customer, it's offer C. This generates £30 worth of value, and more importantly, fits in with our budget of £15. An alternative option may be to send out the highest value offer to 2 customers. This would also fit within our budget. However, the value generated from this activity would only be £28 and would fail the maximised value criteria. So it's not something we'd want to continue with. So, having defined the two core concepts, how do we actually go about doing this? I'm going to go into each of these steps in a little bit more detail in the subsequent slides. But at a very high level, we've gone through a three-stage process. Our initial stage was to generate and collect data around our customers based on a series of randomly selected mailings, identifying a random group of customers and then sending them a randomly assigned discount offer to see how they behave. The second stage was then to take the information gathered from this exercise and build some predictive models. A simple model around the prediction of a customer's response to offers, and then an understanding and prediction of the value generated from each offer, assuming a customer responds. We've applied a series of different modeling techniques and running an arbitration routine to arbitrate between the various different models, and finally feed that output into an optimization routine. This entire system is currently being run on a fortnightly basis, retraining, rescoring, and re-optimizing as it goes. Improving the performance of the system with each additional iteration of the models and with each new set of data that we're putting into it. So let's get into the steps in a little bit more detail. So the first stage is our random offer element, and this is as simple as it sounds. This is purely and simply identifying a set of random customers and then sending them a discount offer through direct mail, email and SMS and observing their performance. The only rules we're applying here is that a customer must be contactable by one of those channels and that they haven't shopped in the last 4 weeks. Beyond that, pretty much anything goes. We have 5 different offers, and also to understand the overall performance of each individual customer type, we have a control group who is not contacted at all. So let's take an example again with our 3 Miss Verries. The first selection identifies all customers who haven't shopped in the last 4 weeks and takes a random sample of those people, and then we randomly assign a different discount offer. In this case, the first customer receives a 15% discount, the second customer a 20% discount, and the third customer receives a £20 off voucher to be used on an order of £50 or more. Having sent the vouchers out, we track the response to it, the sales and profitability generated over the 3 weeks that the voucher is live. 6 weeks after the first selection, the first set of customers receive another offer. In the case of in this example, our first 2 customers have now received a £20 off 50 discount voucher, and our third customer receives the biggest offer of all, a 50 off 100. Again, as before, we track the response, sales and profit over 3 weeks, and then send out another set of vouchers 6 weeks after the second selection. The beauty of the random offer methodology is that it allows us to start understanding the effects of memory and starts to challenge our basic assumption that a customer needs to have a bigger voucher than the one they received previously in order to respond at any given time. Because we're randomly assigning offers, a customer may receive a bigger offer than previously, a smaller offer than one previous, or maybe even the same offer previously, or potentially even held out entirely. And from this, we can start to help use this information to help refine our models into the future. Having set up a series of different random mailings over a period of 2 months, we then started to define our model building process. And this is a 2-step problem. The first step is to say, for each of our individual discount offers, how will a customer respond to it? And then the second stage is, if a customer responds, how much value will they generate? In order to do this, we've taken each of our selection instances, taking in all of the customers who are selected and picking up the vouchers that they've been sent. After this, we're collecting approximately 300 different customer level variables to help us to predict the response and value from this system. This includes information such as transactional and product data, website interactions, account level, and credit data. Once we've built our data set, we're then actually starting to build out our models. The first model, the probability of response, is using a simple binary target. Does a customer place an order in the 3 weeks after receiving the voucher or not? The second model is then trying to understand the value associated with these offers, and this is a lot more complicated for us. ShopDirect's business model is such that for a given value of order and given value of sales, the profitability of the order can be significantly different depending on the types of product a customer's bought and also the way that they have interacted with our credit proposition. This volatility makes it very difficult for us to predict an individual customer value of an order generated from a voucher. So in order to get around this, we've simplified the problem somewhat. For each of our different discount offers, we've taken all the customers who've responded to it and banded up the value of response in each case. We created 4 bins of value: a negative value bin, so that's all the orders that have actually lost us money after they've been placed, and then the positive value orders have been broken into 3 distinct groups: a low, medium and high value bin. From this, we've then built a model to predict for each individual customer which of the 4 bins they're likely to fall into, and then have assigned the median value associated with each bin as the value of response for that individual customer. This allows us to understand the expected value for each individual once we've sent them a voucher, simply by multiplying out the expected value of response by the probability of response itself. Having defined our modelling framework, we then went on a period of exploration into different modelling techniques using the functionality within SaaS Enterprise Miner. Having tried a variety of different techniques, we've alighted on 5 that we've taken forward into our automated system. Simple regression and decision tree models, 2 different varieties of neural network, and a gradient boosting algorithm. We've then taken a 6th approach, an ensemble model, which combines the output of the five other techniques to create another challenger approach. In addition, because we're using so much data, 300 plus variables for each individual customer, there's a very real danger that we're actually going to overfit the models if we leave this system to run on its own. So to combat this, we've applied 2 additional transforms: a principal component analysis and a simple variable clustering approach to reduce the dimensionality of our data. In total, this is creating 12 individual models to predict response to 1 voucher. This process is then repeated to predict value, and each of the models are then arbitrated against each other to get us down to 1 response model and 1 value model per offer. In total, we are building 288 models with each run of this system. 12 response and 12 value models by 6 offers by 2 brands. Having generated the various models and determined which one is the strongest for each offer, we're then taking the output of this process and running it through our simple optimization system. Again, let's take an example using an individual customer. In this case, we understand the likely response value and cost associated with each voucher for an individual customer. So take the example of our 20% discount. We would expect this particular type of customer to have an 11% probability of response if they respond to generate £21 worth of value and for it to cost us £12. Moving further up our voucher stack, at our £30 off 60 voucher, we would expect response to be up at 17% with a higher value at £27, but costing us significantly more at £30. These values are all indicative and will vary significantly by individual customer type. Once we've got that information, we can calculate the expected value simply by multiplying out the factors. So in the case of our 20% off voucher, we're expecting their value to be £2.31. That's simply the 11% response multiplied by the £21 worth of predicted value. However, this isn't the whole story, as we know that this type of customer, even if we don't contact them, is likely to generate value and response and place an order anyway. In this case, we expect this type of customer to have a response probability of 4% even without contact, and a £12 value. So by not contacting them at all, we would expect this customer to generate us an expected value of 48 pence. As such, we need to understand the incremental benefit of sending a voucher over not. And this is simply done by comparing the value we expect from an individual voucher against the value expected from not contacting them at all. Again, in the case of our 20% discount voucher, this gives us an incremental expected value of £1.83. That's the expected value from the voucher of £2.31, less the 48 pence from not contacting them at all. We can repeat this calculation for the expected cost and ultimately generate a return on investment for each of our individual vouchers. Having done this for every customer, we then simply rank our customer file in descending order of return on investment and apply a cut-off at the point at which our expected cost budget is exhausted. So that's a fairly whistle-stop tour of the system that we've built to date. But where are we planning to take this next? Where are our opportunities for improvement? Well, the first and the biggest one is the sophistication of our optimization. As you'll have seen from the previous slide, what we're doing at the moment is very simplistic. It's using the assumption that the best offer for a customer is always the one that generates the highest return on investment and doesn't take into account all the potential combinations of discount vouchers to help us improve our system. The next step for us is to investigate tools and technologies that can help us with the complexity of the mathematics that we will need to actually increase the level of constraint and the level of sophistication within the system itself. At the moment, we are limited by our tool set and our open source environment. However, this is going to be changing over time. The second piece is to better understand our profit prediction. And in this case, we're looking to actually try and deconstruct the profitability of orders in a little bit more detail. Instead of trying to understand the likely profitability of a customer straight up, we're currently working on predicting the sales level we expect to get from a given response, the margin of the product that the customer may buy when they respond, and also a prediction of the credit interest that they are likely to incur once they do. The three models here will then be combined to hopefully give us an improved profit prediction. However, there is also a real danger that the errors within the individual models could multiply out and leave us in a worse place than we're currently in. However, until we try it, we're not going to know, and that's the beauty of our Agile methodology that we're applying here. We can test things out, spin them up fairly quickly, and pull them if they don't work. The final step is to widen out our offer portfolio. At the moment, we're assuming that to bring customers back, we will always need to use a discount voucher. But what if there were product messaging or credit messaging that we could actually implement to bring customers back more effectively? This is an area that we're looking to explore over the next couple of months and hopefully reduce the amount of cost we will incur to bring customers back. And that's it.